Welcome to our extended burst session on integrating language development with content learning in mathematics. This is part of our inclusive practices in mathematics in the middle years series. In this session, we'll explore strategies to blend language skills with mathematical concepts, creating a more holistic and engaging learning experience for students. We'll look closely at the importance of fostering both linguistic and numeracy proficiency and provide some practical tools and insights to consider in your planning. Something to really consider is in what ways we can provide supports and strategies, and how we might design them to promote practices that foster independence and self-determination among students. So this particular series is going to apply one main framework to guide our thinking and practice, and that is universal design for learning. If we take a look at the words in this framework, we do a sentence explosion or a phrase explosion and look at what the words mean independently. For universal, we're talking about all students. And when we talk about students, we want to address and embrace the variability that exists within them. So that's interpersonally, meaning some of the differences that they might have in terms of identity, in terms of their diverse learning needs, in terms of their social goals, and things like that, background knowledge and things like that. And we want to consider how we can plan and create with intention, knowing those things, where we can identify learning goals. We can start to think about what might be barriers in terms of the learning so that we can plan accordingly. And we want to provide lots of opportunities to work towards learning language and social goals. Also, in terms of the UDL principles, there are three aspects that we'll consider all throughout. And that's multiple means of engagement, where we're thinking about how we're going to get students interested in learning math, how we're providing opportunities for choice throughout our lessons, how we can get students to commit to the learning process, even though they face a challenge. And we'll also look at multiple means of representation. And what that actually means is how we can focus on the process of collecting and presenting information for students. In addition to that, we'll look at multiple means of action and expression. And this is where we want to enforce some of our math curricular learning standards that require students to show and represent their thinking in multiple ways. But it's also giving them opportunities to share their progress in different ways too. And one of the larger principles around UDL is that we stick to our firm goals for learning, and in this case, language, but we provide flexible means. So in today's session, we'll look at why we focus on language development. We'll offer some scaffolds for sense making. We'll also offer some scaffolds for mathematical discussions, and we'll think about some possible mathematics language routines. There were a number of resources that we consulted in order to give us some information about how to present the information today. We also have been working closely with students in classrooms and thinking about what strategies are most helpful. So a lot of these have a UDL framework in mind, and are attached to mathematics. You will see on the right, though, there is a reading strategies book that is very supportive in terms of providing tools for students to engage with vocabulary and comprehension. In addition to that, Dr. Shelley Moore's 5 More Minutes has been a good learning tool for us, in addition to Edutopia and some other university articles. Mathematics is hugely connected to language. This is a quote that was offered by Zwires. It says, mathematical understandings and language competence develop interdependently. When we're talking about that, we're talking about that students don't actually need to understand a language completely before they can start making sense of mathematics content. They are able to negotiate meaning in that language. And so learners of all levels can and could be engaging with their content while learning some of the math language and practicing vocabulary. So some ways in which we do that is to really think about our planning and instruction. When we plan and design lessons, we generally think about what are our ultimate goals for curriculum. And we can also be thinking about what goals that we might have in terms of language. So some are written directly in our learning standards in the curricular competencies, like the ones outlined in orange on the screen, where it says express mathematical ideas in a variety of ways, use mathematical vocabulary and language to contribute to mathematical discussions, and to explain and justify mathematical thinking in many ways. But we could be also thinking about what it means to be successful in doing some of those things, and what are some of the scaffolds or things that we could be doing to provide foundation to those skill acquisitions. So, for example, we want to be able to support students with comprehension. And so a language goal might be that they are able to respond to questions and instructions with accuracy. Right. We also might want them to use a broad range of tier 2 and tier 3 words with increased precision. And I'm going to talk a little bit more about what those are in later in the session. So let's take a closer look at one of the UDL framework aspects, and that's multiple means of representation. This is something that we can control in our design of lesson plans. When it talks about process of collecting and presenting information to students, we want to think about what might be possible barriers to learning and identify some of the scaffolds that it might invite students into the learning. So for example, if I'm using text, written text, and I want to think about what are some possible barriers to students being able to gain access to that information in the text. It might be that a student is visually impaired. It might mean that we have a multilingual lingual learner, and they need some support with vocabulary. There might be students have challenges with decoding written text. There might be some also learning disabilities like dyslexia. So we want to think about, okay, knowing our students and what some of those actual barriers might be, what could be helpful scaffolds to them. Things like a focus on building word skills. So understanding and using vocabulary. It might also be that we use multiple forms of text for students to access and choose from. We could provide more opportunities for students to practice using mathematical language and key vocabulary during their small group discussions or with whole group. And we'll talk about what each of those looks like or could look like in a classroom. So let's start with scaffolds for understanding vocabulary and language in mathematics. When we are focusing on mathematics vocabulary, there are a few instructional strategies that we can incorporate in our planning and facilitate as part of a lesson. So something like building and preloading vocabulary and language frames. We could also use visuals alongside some of our oral and written language. We can practice using vocabulary terms of focus throughout a lesson and in our connected activities. So students are seeing that there is a progression in the learning and that the terms are used in multiple contexts. We can use vocabulary terms while we are engaging with materials even. So we want to always try to make math 3D. And that is incorporating as much as possible the use of concrete materials when students have an opportunity to grow their learning and demonstrate their understanding of concepts. When we are talking about vocabulary, there are two types of vocabulary that we can focus on in mathematics. Tier two vocabulary is general kind of instructional vocabulary. It's found in our texts. We need to know it to be able to follow instructions and for us to be able to consider important ideas. They're generally cross-curricular terms. So they're terms that you're going to find in various areas of learning. Things like the word explain or build or compare, contrast, simplify. Then there are tier three vocabulary words, and those ones are more subject specific vocabulary, and those are necessary to understand specific topics or processes. So, for example, in measurement in math, we might be looking at an equilateral, polynomial, or a function and things like that. On the left-hand side of the screen, the visual represents a page on the pillars of literacy. And one of the pillars is centered around acquiring and using languages in context. It's the blue one in the middle there. The pillars of literacy are made in grade groups. This one is for secondary, but there's also one for 6-7s that you can access. And it gives us some direction in terms of how we can be supporting vocabulary word skills in our classes. One thing that we can do is provide some tools for students. When we think about the fact that students might have a barrier when they're reading text, and that barrier might be some of this vocabulary, what can we do to provide tools to support them and tools that they can access at any point that they want? One of those is like a glossary of terms. This is going to be made for available for you on RichNet, and these are mostly instructional terms, and they encompass some of those tier three terms as well, those subject specific terms. But those are definitions, but each of those definitions also has a visual. We could also be looking to create a word wall or to have a poster of these terms that you can have printed and then just pull up as you are using them. And the reason for this is so that students could really comprehend their instructions so that they're able to move forward with their learning or to complete a task. So here's an example of some of those tools and strategies in use. At the top of the screen is an instructional routine. It's what's my rule, right? And the basic premises around this is that there's objects in the small box that are part of the rule, and anything outside is not an example. And then students have to guess what is the rule, and they have to also share their process of thinking and their reasons for why they've come to that solution. So they have to explain and justify. So to be able to support an instructional routine like this, we could be providing some vocabulary tools. So I might have on the board in our discussion, try using these terms. And I might also put up those instructional vocabulary terms that are going to be important to understand. So in this case, I want them to try to use the word rule, fraction, numerator, denominator, and I really want them to understand what it means to justify. Also, to help to support them in being able to express or to be able to communicate using language, I'll use some sentence frames, and some examples of those sentence frames are at the bottom of the screen here. I agree with your suggestion or claim. The process used was, or my claim is, and my reasons are. I might start to think about providing more context if they're younger students. I think because things like that. I also want to share with you two strategies that students can use for building word skills. Some things that you might be doing in other areas of learning can apply to mathematics. For example, word part clues, where we're looking at prefixes and suffixes and really getting students to look at and understand text features and using them to provide context clues. So here's how word part clue works. You provide students with a graphic organizer like you see here, where they write down the word and you help them sort of break down the word into its parts. The base word is what we want to start with, and then we think about what's the prefix, what's the suffix, and then we support students with understanding what each part of those words means, and then together what the whole word would mean. So, for example, in the word subtraction, tract is the base word, sub is the prefix, shun is the suffix. And when you put those together in terms of meaning, under, pull, process, it's a process of pulling under or taking away. And so having those skills that students are practicing in other contexts reiterated in our math classrooms is a good way for students to see the value of those particular strategies. Sometimes I put up an anchor chart like this on the board, just with key prefixes and suffixes for students to have the definition of so that they can help themselves. Because ultimately, the purpose of providing students with these tools and strategies is for them to become really independent learners, knowing when they need to use a support and when they can ask a question. So another strategy that students can be using independently when they come across challenging words is to look at the text features of the page that they're working with. So this is an example of a page in a workbook where we want to suggest that students look at the entire page and think about if there's any clues on the page. So if they're wanting to see, for example, in this one, what the definition of linear is or nonlinear, what are the text features that we can look at that can help us understand what this is? And so the visuals really support understanding what a linear is, right? So based on the picture, what might the word mean? Is it bold? If so, check your glossary, things like that. Something I also provide students with in order for them to sort of process the definitions of words so that they can think about how to apply them in context is a Freyer model. And there's different versions of Freyer models, but um, the ones that are most common are present a graphic organizer for students to define the word, to share particular characteristics of that word or topic, and then to provide examples and non-examples. And this gives them an opportunity to deepen their understanding of the term in context. When we are supporting students with building language skills in mathematics, we also want to think about where language is represented most often. And in mathematics, it's often in written word problems. So we want to think about what are some of the things that we could do to support students with being able to comprehend the question and then being able to support them with entering the problem so that they can start the numeracy process of interpreting so that they can successfully complete the task. So when you think about possible barriers to task completion when it comes to word problems, it could be that they don't know what the context of the word problem. If they're new to country and it's a context that is, very North American focused, we could be thinking about how we can select contexts that connect to students' interests, to their experiences and background knowledge, or we are providing more information about the context so that they have a deeper understanding of the context before they start solving a problem. In addition to that, you want to think about what background knowledge they have and what's required to engage with the task, and have we built a foundation around that? And if certain students require more support around that, what you could be offering. And we also want to think about how we're going to support them in comprehending the instructions, the vocabulary, and the use of that numeracy process. And so, one thing that we could be doing is identifying those tier two and tier three terms that can be defined in advance. And something else that you can try to prevent students from just looking at the numbers in the problem and just trying to come up with that solution super quickly is to present it as a numberless word problem first, and having them really engaged with the problem before you start to add the numbers. So, with word problems, some tools that are successful that students can choose to use are graphic organizers. And I find that particularly helpful for getting students to slow down and to really think about what the problem means before they start tackling it. Um, where they are identifying some of the things that are really important in the problem and things that may not be, right? Also, we could be giving them vocabulary definitions so they can refer to their glossary if it's necessary. So the strategies that they can use independently is something like explode the sentence, where they can circle and define important words that are in the word problem. They can cross out information that might not be needed, and then read each sentence one at a time, highlighting the important information and then recording it into the graphic organizer. So this is something that requires modeling and done step by steps with students before they can be independent and do on their own. And then you want to consider the context a little bit and determine how you can support students in considering the context when they come up with a solution, and determine whether it makes sense. So, tools for understanding text. I just wanted to share with you that there are some digital tools that could support language development. And so when we use a text, informational text particularly, Microsoft Office 365 in any of its applications will have this feature called Immersive Reader, and Word is probably the most useful when you actually have a Word document created and you click on View. Immersive Reader becomes a clickable option. And what you can do with that is provide individual or whole text translation. You can provide scaffolds for supporting reading. So, for example, you can increase word, letter, or line spacing. You can change the background color, or do some word highlighting when it's doing text to speech reading. So students can use this independently. They just need to be taught how to use it. So scaffolds for mathematical discussions. It is really important that students have an opportunity to practice using math language and vocabulary in their discourse with students and with teachers. So one strategy that you can think about is called revoicing. Now, there's two ways that we can think about revoicing, but here's why. It encourages productive talk, it clears up misconceptions, it clarifies students' thinking, and it gives students a chance to correct or expand. So when you're doing some whole group discussions, when students are sharing an idea, you could be repeating back all or part of what they're saying. And then what's really important is that you verify whether you have interpreted what they shared correctly. Did I say that correctly? Is there anything that you would like to add, or something else that you've thought of? And that gives them an opportunity to expand on their thinking. There are some helpful suggestions for how to do that in the top left where it says talk moves. Another option for doing that is when students are completing a task, and or you're reviewing a particular process for or for finding a solution to a problem, you can have the students think, pair, share, or repeat the process that you used. And as you're circulating around, listen for how students are sharing that procedure or process. And that gives you a indication of if they've acquired and used the language appropriately, and or the actual steps in the solution are clear. You can give students some sentence frames that you see at the bottom there for questions and responses, so that they know how to have that discussions with their peers. Something else that's really useful when students are working either in pairs or small groups are talk tents. And talk tents can be 3D like the ones that one you see at the bottom of the page in yellow, or they can be flat if they're working side by side. And what they do is they provide students with like some supports for having conversations about a task. It gives them an entry into the task. And so the talk tent can include sentence frames, it can include definitions, it can include an elaboration of a context and or visuals. Here's an example of one on the right-hand side. This is a side-by-side talk reference. And so if the word problem is like the one you see on the left, this is from MathLink 7. Mandalas are used in many cultures. A mandala is thought to bring happiness and good luck to its owner. Draw a circle with a radius of 10 centimeters. In pairs, design a mandala and explain the significance of your finished product. When students are working in pairs to complete a product like this, it's helpful to give them an entry point into the problem. Sometimes a visual is helpful. A visual doesn't have to include every single item that's on here because we want to give them an opportunity to interpret and use some of the learning that we've done. So in the visual, it shows the diameter, but not the radius. And then some of the thinking and talking points that are available are going to provide direction for how to complete the task, or to engage students in conversation about mandalas. Something to consider when offering a word problem like this, particularly if it's just a question in a textbook like this one, is how we might develop collective understandings about what mandalas are and their significance to our students. So how do we sort of create more of a learning around this, to make it, a more of a focus in the learning process? Something you can also provide are sharing and building sentence frames like you see at the bottom of the page there also. There are going to be more inclusive practices, supports available on RichNet. At the bottom of each grade brand, you will see tiles that you can click on. The one that is titled Inclusive Practices will be populated with some ideas, instructional strategies, and links to these particular burst sessions. Think about in as you reflect on some of the learning in this session, in what ways you make your math instruction engaging and inclusive for students, how you are supporting students in strengthening their math identity, and consider your next unit of a study or lesson sequence, and think about how you might embed language development with content learning.